Hello, and thank you for clicking on this video. This video lesson is going to cover square roots, what they are, how they work, and how to simplify them. As always, please like this video if you find it helpful, subscribe to the channel for more math content, drop a comment or a question to engage, and please check out some of the other playlists and videos on the channel. We've got playlists on everything from multiple choice questions to algebra tiles to how to use Desmos as a calculator. So first off, square roots, what are they? And so we want to be really clear about what they are. One of the most common misconceptions that I see in my classes is a confusion of square roots with squaring. And they are, of course, related, but they are not the same thing. So the symbol for a square root looks like this. Okay, and I have seen students write it. I'm going to go up in the upper right corner here like that. That is not a square root symbol. That is a long division symbol. Okay, it is not the same thing. And I've seen students also use a square root symbol when they meant to use a division symbol. So we do want to make sure that we're clear on that. Under the square root, you will have something written, and that something is called the argument. And the argument of the square root could be a number, it could be variables, it could be a combination of numbers and variables. And you might also see a little 2 tucked into the little hook on the square root symbol. Now, typically you don't see a 2. If you do not see a number there, the assumed number is a 2, but you might see the same symbol later on, and you might see a 3 or a 4 or a 5 just kind of tucked in there. But if you don't see one, it's assumed to be a 2. But if you do see a 2, it is a square root. Now, this symbol is also known as a root or a radical, and you will hear me use those as I'm talking about them. I'll say, simplify the root, or when I'm reading something out loud, I'll say the word root or word radical. So what does this symbol do? First of all, it's an operator. It tells us what to do with a number or expression. So if you were to see the square root and then you see a 5 underneath it, the symbol tells you to do something to the 5, okay? And the way we would say that is you're going to take the square root of 5. That's how we would put it in words. So first off, it's an operator. It tells you to do something like a plus sign or a minus sign. It's asking you to take an action. What the operation does is it undoes squaring. That is, it finds the expression that when squared will give you the argument, okay? And so we can look at some examples of that. We'll look at some examples on the next slide. Now, another thing about the square root is that the answer is always non-negative. And, I almost wrote positive there, but it can be 0, okay? It could be 0, but it's never negative. If we need to consider negative options, we'll need to indicate that. And that's a little hiccup that when I was in school really, really bothered me because it felt very random to me that there were times when we could just take a square root and we'd take the positive number and that was fine. And then there were other times when my math teacher would put this plus or minus in front of the square root, and it felt random to me when we would put those positive and negative. So as we come up on that in these lessons, I'll try to be clearer than my teachers were in explaining when. But if you were to simply just see something under a square root, you would assume it is the non-negative number or the positive number. So here's an illustration to get the sense of what square roots do. So on the left here, we have the operation of squaring. Okay, so we have 3 squared, 4 squared, 5 squared. And when you square 3, you get 9. And so I often think of this as one direction. You take a 3, you square it, and you get 9. The other direction is to take the square root of 9 and that will allow you to go back and get the 3. In other words, it's asking you what number squared would give us this number under the square root here. And so you're going backwards. And that's why actually, I mentioned earlier, sometimes you'll see a little 2 tucked in there, and it's the 2 that actually matches the squaring. So it tells you that these are a pair of operations. It's similar to this. If you were to have 3 plus 5 is 8, and then you were to do 8 minus 5, and it would bring you back to the 3 again. And so you have this pair of operations. Adding does one thing, and then subtracting undoes it and goes backwards. Well, squaring does one thing, and then the square root here does the backwards thing and brings you back to where you started. It's actually called an inverse operation. 4 squared is 4 times 4, that's 16. And then the other direction would be the square root of 16 is 4. And so you end up back at that 4 again. And then last but not least, we've got 5 squared is 25. Therefore, the square root of 25 is 5. And make sure that you are speaking correctly about this, that you're speaking in your head correctly about it. So you're not saying squaring when you mean square root or vice versa, so that even in your internal monologue that you're having, that you're using the right words. Now, note the perfect square numbers. Perfect square numbers are our integers squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And typically, we can go a little bit further out than that. You've got this set of numbers that are called perfect squares, and there's actually an infinite number of them. So these are your perfect squares. Typically, we only go up to 100, 121, 144. Up to your times tables that you might memorize in grade school. Those numbers are your perfect square numbers because they are the numbers that result from squaring an integer. They can come in pretty handy. All right, so here are some simple examples. I'm just kind of working through how square roots work so you can get familiar with them. So the first example up there is just the square root of 36. So it's asking you what number squared would give me 36, and the answer is 6. Now, this is what I was alluding to before. When we take a square root, we always assume the positive number. And somebody watching this video is probably thinking, well, it is true that 6 squared is 36, but it's also true that negative 6 squared is 36. So if all you're doing is just taking the square root of 36, you assume the positive 6. So you don't answer that as negative 6. But there are times when we do need to remember that, and so we would end up putting the negative in front of the radical. In fact, most of the time it'll end up with this plus or minus symbol in front of it. And this would be our way of getting the negative 6. Now, I put the 0 on there in part because a lot of my students will just tell me, oh, you can't take the square root of 0. But again, remember what the square root symbol does. It's telling you what number squared gives you 0. Well, 0 times 0 is 0. So 0 squared is 0. Therefore, the square root of 0 is 0. So don't overthink that. If you are taking the square root of a fraction, you can actually do this, and this is probably one of those things that we could prove in another video. We won't do it at the moment, but you can take the square root of the numerator and the square root of the denominator, and so square root of 16 is 4, and the square root of 25 is 5. Now, when you get to the square root of 3, this one is going to cause some issues. So, if you think about, well, 1 squared is 1, 1 times 1 is 1, and 2 squared is 4, and we're looking for something in between them. And so the square root of square root of 3 is 1 point something, okay? And I might not know, really? Something, there we go. off the top of my head what that something is. It's 1 point something, but I know it's in between 1 and 2. And something to know about that decimal is that it is irrational. So I'm just going to say it is irrational, meaning it is a decimal that can not be written as a fraction. It never repeats and it never ends. And that is, I know when I went to grad school, that was one of the first things we had to prove. We had to prove that the square root of 2 actually was irrational. That there was no way to write it as a fraction. And so the square root of 3 is irrational. In fact, most of your square roots are going to be irrational. The only ones that will be rational are the perfect squares. Those are the only ones that come out nice. And then this one here, the square root of -9, and I want you to pay close attention to where that negative is. If the negative's out front, like we're good to go. Negative of the square root of 36, well, square root of 36 was 6, therefore it's -6. But what if the negative is under the square root? Okay, so we want to know what times itself would give me -9. Well, imagine for a moment that you picked a positive number. Well, a positive number times itself would give you a positive number. Okay, any positive number times itself. But it's also true that a negative number times itself, okay, because that's what it means to square. So you're going to multiply it by itself. So if you take a negative number and you multiply it by itself, so that's another negative number, a negative times a negative also will give you a positive. And there's only one number that is not positive or negative, and that's the number 0. But if I square that, I get a 0. So you ask yourself, is there any way that you could square something and get a negative number? Well, not with the tools that we have right now. And so this one, I would tell my students to say, not a real number. You say, what do you mean, not a real number? You mean that there's unreal numbers? Well, sort of, yes. And they are not studied in Algebra 1. So if you're interested in that, you do want to check out some Algebra 2 videos where we can talk about what that is. But for now, it's just simply, it's not any kind of number that we know. If we square a number, we're either going to get 0 or a positive out of it. We're not going to be able to get a -9. Most common incorrect answer that students give is -3, but remember, -3 times -3 would actually give you +9. So for now, that would be not a real number. All right, so what does it mean to simplify a square root? Years and years and years ago, I tutored a student over the summer, and she was preparing for Algebra 1 and had all kinds of Algebra 1 summer homework. And one of the assignments was to simplify some square roots. And all she did was put them in the calculator and change them to decimals. Well, remember that I said most square roots are actually irrational numbers, meaning the decimal actually does not end. So even if you write out all of the decimal values that your calculator will give you, it doesn't actually give you the exact value because you're having to cut them off. And so I had to explain to her, like, that's not what it means to simplify the square root, which is probably not what she wanted to hear. But what does it mean to simplify a square root? Well, it means to get the smallest possible number under the root. So if you have a big number, okay, under the square root, you want to simplify it so that you have a small number under the square root, and then you'll have a number outside multiplying it. So it'll be some number times a smaller number. And that's what it means to do the simplification. It doesn't mean get rid of the square root by using your calculator. What we do to do that is we do that by finding factors that are perfect squares and then taking those square roots. So I mentioned earlier, you look for factors that are perfect squares. Now, 1 will be redundant, but you look for mostly 4s and 9s, quite frankly, but sometimes 16s. 25 is actually pretty common because if you were taking the square root of, say, 50, you would have 25 as a perfect square and so forth. So you would look for factors that were perfect squares and then take those square roots. So I'm going to show you how to do this using a foolproof strategy. And I'm actually a big fan of this. This is not how I was taught, and I will show you a quicker way, like what I would do, being somebody that's done this for a very long time, because I wouldn't typically use this strategy, but this strategy is foolproof. And when you get to other kinds of roots that have numbers other than 2, so maybe you've got a cube root or a fourth root, or this strategy will continue to work for you, even when you kind of jump ahead and look at more complicated radicals that you don't know what the factors are. So I encourage you to learn this strategy, even if you end up not using it a whole lot right away. And the strategy is this: to go for your prime factorization. So I'm going to take that number 8 and I'm going to factor that into 2 times 4, and then the 4 factors into 2 times 2. Okay, and so the prime factorization of 8 is 2 times 2 times 2. So you want to get good at breaking these numbers down. Now that you've got it broken down, so all I did there was I factored the 8. I'm going to look for stuff that's squared. So right there, I have 2 squared. Okay, and here's what we know about square roots. A square root undoes squaring. So this squaring right here is going to be undone by the square root. Well, the square root of 2 squared is just 2. Okay, that's like literally what the square root does. And so the square root of 2 squared is 2. And then you're left with 1 2 that is still under the square root. And so essentially what we're doing is we're looking for everything that can be like paired off as squaring, and getting it out. So I'll show you another example. We'll do the square root of 12. And again, I'm going to do what's called the prime factorization. So I'm going to factor that into 3 times 4, and then the 4 would get factored into 2 times 2. And so the prime factorization is 3 times 2 times 2. And remember, this is a square root, so I'm going to look for something that's squared. Well, there it is. There's the 2 squared. The square root of 2 squared is just 2. And then the 3 is still underneath the square root. Okay, make sure that the 3 is still under the square root. Now you might say, well, wait a minute. What if you factored the 12 into 2 times 6? Okay, well, you have 2 times 6, and 6 is 2 times 3. And what I want you to notice is that you actually get the same collection. That's why prime factorization is so useful, because even if you factor it like a different way on the way down, like somebody picks 3 times 4 and somebody picks 2 times 6, by the time you get everything factored out, you'll have the same set of numbers. And so you'll be looking at the same set of factors. Let's take a look at one more. So we've got 18. And again, we're going to prime factor it. So some of you are probably saying, oh, that's like 2 times 9. And some of you are saying, oh, it's 3 times 6. It doesn't matter, because as soon as you see something that's not factored, you're going to go ahead and prime factor it. So we should end up with 2 3s and a 2. And we're looking for things that are squared. So there's 3 squared. Well, remember that square rooting undoes squaring. So the square root of 3 squared is 3. So it'd be 3. And then that 2 is still hanging out under the square root. Okay. So the thing that you take the square root of, it comes out of the square root. What maybe might make it a little bit clearer, I'll show you this. So you could do it this way. You could say 3 squared times 2. And then you got the 3 squared times the square root of 2. And this one right here that you're taking the square root of, that's the one where the square root goes away because you undid it. This one, we're not really taking the square root, and so it stays underneath. Okay, now how much work is required when doing these? This can vary depending on your teacher's specific requirement. So what your teacher specifically requires you to do always trumps anything that you see online. You follow the directions for the class that you're in. The amount of work can vary depending on the strategy you use. So if you are doing this prime factorization, you're going to have some scratch work and you're going to have some middle steps that maybe if you're using a different strategy, you're not going to have those steps. And your personal skill level with numbers and multiples. The better you know your times tables, the faster you'll be able to do this and the fewer steps that you will need to do. And that's going to vary from student to student. So some of you probably drilled and killed your times tables in elementary school. Others of you did not drill and kill your times tables in elementary school. So we're going to look at this problem two different ways. So we've got the square root of 72. And if you're prime factoring this, you're going to need to break it down. And for most people, what they see on that one is 8 times 9. 8 factors into 2 times 4. 9 factors into 3 times 3. And then that 4 is still not factored all the way. That's 2 times 2. Okay. And so the prime factorization there is 2 times 2 times 2 times 3 times 3. And it's a square root, so we're going to look for things that are squared. Well, I see a 2 squared and I see a 3 squared right there. The square root of 2 squared is just a 2. The square root of 3 squared is just a 3. And so we will have a 2 with no square root over it. We're going to have a 3 with no square root over it. And then we've got that 1, 2 that is still stuck under the square root that we couldn't buddy him up with anything. Watched a video years ago where a guy talked about like busting them out of radical jail. Was the analogy. We're going to bust them out, but you got to have a jailbreak buddy to get out of jail. You need your buddy to get out of jail. If you can get out of jail with your buddy, you're good. 2 doesn't have a buddy. And 2 times 3 is 6. And so that simplifies into 6 root 2. Now, this is the way that I would do this. I would, because I've done this problem a million times, I recognize that 72 is a multiple of 36. So that's 36 times 2. And I know that the square root of 36 is just a 6. And then the 2, I can't take the square root of, and so I would do it that way. So you can see that that's actually a lot less work to do. But again, it depends on what your teacher wants to see, which strategy you're using, and your personal skill level. One other way you can do this problem that I've seen a lot of students do is they recognize the 9 times 8. And so they say the square root of 9 is 3. So they have a 3 outside and then the 8 is still staying in there. The problem with this is that it's not simplified all the way. So to simplify, you want to get the smallest number under the square root possible. And this one has an 8 and we know we can get a 2. So what you would do in this case is you would actually need to continue and say, okay, we have the square root of 4 times 2. The square root of 4 is 2. So now we have 2, and then that 2 still stays underneath, and you can eventually get there that way. So you do have some options, but whatever strategy you use, you want it to make sense, and you want to land at 6 root 2. Okay, one last example to prep for what's to come. This lesson is way longer than I thought it was going to be. So this is something that you are going to see in future math classes, not too far from now. And I have no idea why there's a slash there. That's kind of weird. But it says evaluate. So evaluate, it's been a while since we looked at evaluating. That means to plug in the numbers and tell me what it's equal to. So we've got our square root. We've got b squared. B is 3. Now, I am going to put the b in parentheses, and I do have a reason for doing that. It's because if your b is negative, you will want it in parentheses. A is equal to 2, and c is equal to -1. Order of operations, we're going to square that first. 3 squared is 9. And then what might be helpful is to remember that minus is a plus negative. So you've got -4 times 2 times -1, which is going to give you a positive 8. And then 9 plus 8 is 17. And then you look at 17 and say, no, I cannot factor that. And so we are done. So that is just want to get you used to seeing that. That's going to become critical later on. All right, that's it. Don't forget to give this video a thumbs up if you found it helpful. Subscribe to the channel for more math content. Give a comment below and check out some of the practice set on this lesson. I'll try to link that above, and some other videos and playlists on the channel. And I will see you in the next one.